Welcome to the new Cyber Frontier, bringing you the latest news on the local Colorado economy and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host, Chris Gorog, brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. Chris is personable and opens up with our guests on the issues we all would like to see addressed. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's New Cyber Frontier.
So welcome to today's episode of New Cyber Frontier. We have an interesting show for me today because I'm really excited about our guest and what our guest represents, very much in my wheelhouse for several years. But Paul Brager today is on. He is the product security leader at Baker Hughes GE. It's a new entity formed by Baker Hughes and GE. Paul will talk about that. But he is a CISSP, a GICSP, and CISM as far as credentials, all in the security, and definitely of value for what he's doing. So Paul, welcome today. Thanks for joining. How are you?
I'm doing well. Thank you guys for having me. As was mentioned before, my name is Paul Brager. I work for GE, or BHGE, the combined entity of Baker Hughes and GE, basically creating the world's first full-stream oil and gas services entity. My capacity there is to work with the business and engineering to make sure that we are following standard processes around security integration into the engineered products. In effect, trying to put the security and bring security closer to the hardware and software and the solutions, and certainly enabling our business partners as well as our customers to have some degree of sanity around the security of the products that we're delivering for them.
Some sanity.
Background-wise.
Oh, go ahead.
Yeah, a little bit of sanity. Certainly, my background, I've been doing cybersecurity in one capacity or another for about 23 years or so. I have my bachelor's in political science, interestingly enough, and a minor in business from Texas A&M. Then I have my master's in public policy. And so it would seem a little odd that I would be doing, heavy industrial cyber. But it actually was a good fit for me. I've always been kind of a heavy engineering nut. But I've worked in oil and gas predominantly for about 15 years-ish or so, in various leadership capacities as well as engineering and architecture. I've worked for petrochemicals, I've worked for manufacturing, I've done consulting. So I've kind of been around the block a little bit. Industrial still is kind of my passion and my love.
Yeah, Paul, are you from Texas? You said Texas A&M. What's your background before you got into the workforce and security? What was little Paul like?
I was a student. I was a student at Texas A&M. I am a native Texan. Grew up in East Texas, in Tyler, Texas, and graduated a salutatorian in my high school class. Went to Texas A&M, got my degree, came from there, came straight to Houston, and started working with a telco provider that is no longer amongst us.
Yeah.
And learning a lot, learning about communications and communication links and networks and that kind of thing. And then the progression kind of went from there to, at the time, security and remote access, things like that were fairly new. And I had a project where I was handed a device and said, make it work. Mm-hmm. So I spent many sleepless nights trying to figure out, A, what it was, B, how it worked, and how we could actually productize it.
Yeah.
Was able to do that, and then a number of presentations, and it became one of the more popular products that the company had for a couple of years or so.
Yeah.
That was really kind of my heavy launch into cyber, or into security generally, information security. And then it just kind of went from there. It was, it was something that was really, really interesting to me. And, the more I dug, the more I wanted to dig. And so
Yeah. So how'd you survive? You're in Houston now. How'd you survive the hurricane? Any problems personally, or?
I mean, everything was fine. I had a little bit of roof action going on in my house that I had to get repaired. But I live north of Houston, about 40 miles ish or so, and so we didn't get much of the flooding or anything. There are some areas that were a little bit south of me that had a number of homes destroyed from flooding and things like that. But for the most part, certainly my family and I are fine. The office building, the office building didn't fare so well.
Yeah.
It gathered some water, and it was kind of difficult to get to it for a couple of weeks or so. But that's starting to get back to normal as well. So, all in all, Houston is a fairly resilient city. The challenge that we have is that it's a city built on top of bayous, and so any sustained rainfall, will definitely result in flooding of some sort. And so when you have that kind of rainfall in that period of time, it's a guarantee that you're going to get some flooding, and it's just really unfortunate. And so my thoughts and prayers continue to go out to everyone who lost homes, but not only homes, but actually, family members. I mean, we had a number of deaths as well associated with this.
Yeah. Well, I'm glad to hear that you came through okay, and we're going to take a break, and we'll be back to talk to Paul.
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org.
So welcome back. Today we are talking to Paul Brager from Baker Hughes General Electric about the cyber and the physical system part. I think we're going to talk about, Paul, here. But tell us exactly where do your products cover and what types of things you support there.
So the effort that I'm a pretty integral part of is working with a number of our engineering teams. So if you can imagine an oil and gas entity, an oil and gas drill field support, or pipelines, or even refining equipment, refining capabilities, has a pretty significant amount of industrial components. And those industrial components manage everything from the actual drill process itself to monitoring and managing downhole type activities, types of things coming out of the ground, temperature, sensors, all types of other components. And so what my role is to make sure that the components that are being productized and that are being sent out to be used and leveraged by customers actually have security baked into the infrastructure and security baked into the capability, and that we are delivering solutions that are, at least from our perspective, are as secure as they can be. Now, there is a bit of caveat in that, obviously, that we as a manufacturer we can certainly provide recommendations and things like that, and certainly work with our customers to secure their systems to whatever standard or whatever risk tolerance they have. But certainly, we do our part, to make sure that our components are as secure as they can be when they leave the door. And so I spend a lot of time working with engineering, spend a lot of time, engaged within the SDLC and NPI processes to make sure that security is being accounted for at every step of development, up to and including the release of the product into the customer's environment.
Okay. So, and your primary concern there is the cyber and the security of it. Where do you see the industry going with risks, and what are your primary risks that you're looking at?
So, one of the things that, that I think that we're all very aware of is that the ICS environment, or ICS environments in general, were never really designed with security in mind, or at least cybersecurity in mind. They were really designed more for physical security, resilience, and operational efficacy. Now that we are having a lot more components that are, that are internet enabled or network enabled, as well as the introduction of IoT into that space, information being pumped into the cloud, and even now some management of components in the cloud.
Mm-hmm.
Obviously we've increased exponentially the attack surface for components that were traditionally not designed to do this. And so, obviously, one of the concerns, risks I have, probably one that's shared by everyone, is what exactly does that mean, right? And how do we defend against attacks? How do we detect the attacks? Many of these solutions use very proprietary protocols, very proprietary networks and communication capabilities that make even monitoring them very, very difficult. And then beyond that, there's kind of a knowledge gap between traditional cyber and industrial, and understanding, okay, what exactly is not normal, or what is normal traffic. It's not as cut and dried as it is in a traditional IT environment. When you're an operator, the operator knows what the system is supposed to do. They don't necessarily know if it's broken or malfunctioning because of a cyber event or an operational event. And so that bridging gap isn't quite there yet. And on the converse of that is cyber professionals, unless they're specifically trained for the ICS control environment, they're not going to necessarily know what they're seeing either, because there may be conditions or may be caveats that are indicative of that space that the operators are perfectly fine with, but that may look very, very, may look very nefarious from the standpoint of a cyber professional. And so it's a very difficult space to monitor.
Yeah.
And subsequently a very difficult space to respond to.
Yeah, and a couple times you said ICS, which stands for Industrial Control Systems. I just wanted to, define that acronym. You said that a primary, cyber area you're looking at is connecting the virtual, the data, and the physical. Explain that and how that pertains to the needs for cybersecurity that you're seeing.
So, obviously, there's been a need or an increasing need for the business, and I use that term kind of in quotes, to have access to data that's being produced inside of these controlled environments, either for business decisioning or forecasting or yield management or any number of particular situations or use cases. And as there's becoming more and more need for this data, certainly the amount of connectivity that's required in order to support that is increasing as well. Many of these industrial environments have very low bandwidth because they're out in the field somewhere. They're literally out in a field somewhere that has microwave line of sight or satellite imaging in some instances. And so you are pulling and dragging this data across open air. And in many cases, it's not encrypted because it can't be because of the latency requirements. And so from the standpoint of trying to build or architect a solution, architect the environment in such a way that it gives you some defense in depth in the industrial space can be really, really challenging. Because again, you are, for every layer of cyber or every layer of control that you put in the environment, you run the risk of either impacting the operations of the components and or B, the latency of those components. And many of these things sample at rates of every 1 second or even milliseconds some cases, depending on what the set points are.
Yeah.
And so it makes it very, very challenging to try to embed and to try to put inline security controls in these spaces. And so the more logical solution, or the more logical situation would be to actually put security and embed it into the solution itself so that it runs at component speed.
Yeah. So let's take a break real quick. We'll come back to talk to Paul some more after we hear from our sponsors.
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Over 3 million data breaches happen every single day. That's over 2,000 records being compromised every minute. So often, we focus on securing web data access. But what if the attackers are already inside, having gained direct access to your storage through data management software? When it comes to communications that go directly into your storage devices, make SNIA your first line of protection. SNIA's conformance testing limits outdated communications that are known to be used by attackers. It works continuously behind the background to make sure your storage is protected. To find out if your data is truly secure, visit our website at www.snia.org/cybertest.
All right, welcome back. We're talking to Paul Still from Baker Hughes General Electric. Paul, I was listening to you talk about connecting the physical and the data at runtime, at the ability to make it the performance of the machine. And a couple years back, I had worked for a utility company, and I kind of wanted your thoughts on this and how we could make this connection, because it's becoming another real issue that I think is very related to that connection between physical and virtual. But a utility company that had for years prosecuted power theft, companies that, or customers that were either inadvertently or on purpose subverting their billing structure, and they had all these records of power usage in their database, and they would take them to court and make forensically prove that this customer wasn't paying for the power, and here's the records of it. And they got to a point a couple years ago where they couldn't prove in court anymore. The forensics trail from those meter reads, where the information was coming from, distributed all over the city, connected to the data in their database. It became just a lump of data that had been transferred through so many data systems that they couldn't make a proof back to it isn't just an error. They didn't make an error in collecting it and sampling it and transferring it around, and that it actually should be forensically billed to that customer and proof that they're not paying for their power. And they lost that ability to actually prove their data. I was wondering what your thoughts are in seeing that in the market related to what you're talking about here.
So you bring up an interesting point, this notion of kind of non-repudiation, or the ability to be able to verify data that's coming out of an industrial environment or in any controlled environment, and put more towards a more enterprise use. So it kind of depends, right? It kind of depends on where the data is emanating from. In certain instances, the data is actually spined, so it will actually be spined by the component that is creating it, and then it'll be pushed into something, typically some sort of primary historian or something like that in the control environment, where there will be a number of data elements that try to uniquely identify where that data came from. What typically happens, though, is that data is then pulled out of the historian and it's enriched somehow. It's either provided with additional data from something else, from another system somewhere, or it's sent to some sort of cloud provider or something like that to kind of, to try to extrapolate if there's missing set points and missing data points, try to extrapolate and create, kind of a smoothing of the curve, if you will. And so that typically will obfuscate the data, certainly, and it removes a lot of the forensic value from it. So it's a very challenging, situation. In oil and gas, particularly, you don't have that type of concern. There is no theft of anything, at least not in that extent. Where you're more concerned capture that data within a certain degree of parts per million, and that information has to be accurate, and it can't have any misses. And so, in those situations, obviously integrity and non-repudiation of data is very, very important. But typically the solutions, the applications, and the solutions that are actually capturing that data have some signing capability to try to handle and deal with that. But it really just kind of depends. Kind of depends on the use case. And
Yeah.
how confident you can be in the data that you're getting.
Yeah, but I think on a base level, that is a big kind of gap with internet or industrial controls, is that this data is used to make electromechanical operations and decisions on billing that has to be accurate. So the accuracy of data and the ability to prove that with non-repudiation is big.
Absolutely, absolutely it is. And again, for in a use case such as power generation and distribution, the ability to track that data and subsequently, follow it back to its source, may be the difference between billing one customer more than what they used, or billing one customer less than what they used.
Yeah.
And I mean, a lot of that again is reconciled today. A lot of that stuff is reconciled in a back end, with databases and ERPs and that kind of thing, and they try to reconcile it that way.
Yeah.
But again, it all bad data in, bad data out, right? So it doesn't, if the data itself, if the source of the data itself, is not competent, then certainly necessarily the result of the manipulation of that data is not going to be competent either.
Yeah. So you had mentioned talking a little bit ago that there was a knowledge gap between IoT, between industrial controls and information security. Can you give us some of your ideas about what needs to be done to bridge that gap, and how we can start looking at training the next generation of workers, of workforce in that area?
Sure. So we in the industry have started to make some pretty significant strides in that space, because we've recognized that it is a fairly significant gap. The traditional IT doesn't necessarily work in an OT environment. However, traditional IT is being integrated into OT, operational technology. So what's happening is you're seeing kind of this convergence of sorts where the lines are being blurred again. It used to be where OT and IT didn't talk unless they just had to. IT was not allowed to touch anything in OT ever, because they would either break it or would hurt the OT guys in some form or fashion. So they kind of got their hands swatted if they go away. But what we've all recognized is that there's a skill and knowledge gap, particularly around cyber. OT guys, for the most part, are not cyber guys. Many of them aren't even IT guys. They're engineers of some sort. And they have, kind of some fundamental knowledge, obviously, about IT systems and how they work, but they certainly don't have the expertise or the background to look for vulnerability, evidence of breach, and those types of things. And so, different companies have approached it different ways. I've seen everything from this kind of sort of a security by committee, where there are industrial control representatives, so OT representatives, IT representatives, and cyber representatives all in the same room on a committee of sorts, and looking at these types of concerns and risks within the environment. I've seen kind of an exchange program of sorts where you take traditional IT cyber people and you embed them in a refinery for a period of time, and you have them work very closely with the IT resources that are there managing the refinery, and actually have them spend time with the control engineers and things like that to understand how they work. Because one of the things when you're trying to build strategy around how to defend something, you have to have a clear understanding, or at least a really good understanding of how it functions and how it's supposed to work. and subsequently what it looks like when it doesn't, so that you as the security professional can bake some sanity around that as well. You're not there, you're not there, chasing your tail. Additionally, I've seen even situations where IT security basically took, a few of their resources and trained them up on kind of the control environment aspects of whatever entity they work for. And those resources became kind of the ICS response resources, if you will.
Mm-hmm.
So there is no silver bullet, obviously, and there's no one strategy. It just kind of depends on the company's dedication to it.
Yeah.
And then what they're able to invest in resources and things like that as to what model actually works the best. But what you can't do is you can't secure by inquisition. You can't force security downward on a control environment because we simply don't have the knowledge. You don't have the knowledge of the space to be able to do that. It has to be a collaborative effort. There's no other way to do that.
Yeah. Yeah, this has been great. As far as what you're doing, kind of in closing here, as far as what you're doing over at Baker Hughes GE, is there any shout outs you want to give or things that you could use support on or industry awareness to?
Not really. I mean, certainly, we have, I have a number of friends, a number of people that work in this space as well, for Siemens and Honeywell and some of the other manufacturers and industrial. And certainly, I think we're all in this boat together. Where even though we compete on a corporate scale, at the end of the day, we're all in this cyber fight together. We have a number of nation states that don't like us very much, and I think the IT vulnerabilities that we see are going to become more of distractions, and I think the larger targets and the larger fruit are certainly going to be our industrials, attacking our power grids, attacking water supplies, financial systems, and those types of things. Looking to interrupt or somehow disrupt our ability to be able to function. Those things can be used obviously in some sort of armed conflict as a force multiplier of some sort, or it just be just as a matter of it being a nuisance. But I think that if we're kind of behind the eight ball in an industrial, and we really we've made really good strides. We continue to push, but there's more of them than there are of us.
Yeah.
And we simply don't know necessarily where they're coming at us from. They could very well be here in the United States. And they could be people that are, both empowered and enabled to be able to really kind of wreak havoc in our environments. And and our ability to monitor and detect that, is good and bad in some instances. It just kind of depends on the industry.
Yeah.
And so, certainly we need to get better. We need to get better at being able to detect, and understanding what net normal is, as opposed to, have kind of, the security, fire by blindside security, where we're just kind of hoping and shooting in the dark. And so I think that's, if I have anything to kind of leave as a parting message, certainly, we have to continue to be vigilant. We have to continue to try to understand our adversaries, understand, the actors, and to the extent that we can, we're not going to stop them from affecting or impacting our infrastructure, but we can certainly slow them down. And if we can slow them down enough, then we can manage the rest.
Yeah. Well, thank you very much, and it's a good closing message, and thanks for joining today, Paul. You have a great day.
All right, thank you very much. Appreciate it.
All right. The views or opinions expressed by me during this podcast are my own and are not those of my employer, Colorado Technical University.
have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.